The Vertica Analytics platform is purpose-built from the ground up to enable companies to extract value from their data at the speed and scale they need to thrive in today's economy. Each of these blocks represents a foundational element of Vertica: columnar orientation of data, advanced data encoding to reduce disk usage, automatic database design to simplify building your database to match your performance metrics, a distributed and redundant database that functions even through hardware failure, parallel query processing through a large number of distributed nodes, and a seamless integration into your existing solution ecosystem. We'll highlight each of these features in this video, and if you're interested in a more detailed explanation of these topics, see the other Vertica Foundation videos on this channel. Let's take a look at this simple query and how row store and column store databases access information. Row store databases store their information in tables. This makes them ideal for interactions where collecting information is paramount. A row store database must read all columns in the tables named in the query, regardless of how wide the tables are or how many columns are referenced. This limits the speed at which you can get an answer to your query. In contrast, the Vertica database transforms the information from a table into a column-based structure we call projections. For this query, we're only referencing 3 of the columns from the table: symbol, date, and price. So these are the only columns that need to be contained in the projection. You will get a faster query response by not having to reference all of the information contained in the table. Vertica significantly reduces its storage footprint by encoding and compressing data, and returning query results from that encoded data. Vertica supports a number of encoding algorithms. The one chosen for each column in a projection is dependent on the type of data in the column, its cardinality, and whether the data is sorted in the column. This table shows a representative sample of the encoding algorithms in use. Block dict encoding creates pointers to distinct column values and is used for character data with low cardinality. The data does not have to be sorted. Delta range comp encoding stores the difference between each value in the sorted column. It operates on a high cardinality floats. Delta val encoding stores the difference between each value and the first value in the sorted column. It also operates on high cardinality data, but can be used with integer values and any number of date-time formats. RLE, or run length encoding, keeps account of each distinct entry in a sorted low cardinality column. It can be used for any character or numeric format. There are many more encoding types supported by Vertica. For the full set, see the direct link to the encoding types documentation in the notes below. Vertica includes the Database Designer, a tool that minimizes the DBA's burden of optimizing the database for query performance and data loading. All you have to supply is the logical schema, or the table structures you're basing your design on, a set of representative data and queries, and your design's parameters and optimization goals. The Database Designer will develop a recommended design for the physical schema, that is, the list of projections that will best meet your stated design goals. For more information on how the Database Designer functions, see the Vertica Database Design video on this channel. Vertica is designed for high availability, or the ability of the database to continue running even if a node goes down. Consider this sample cluster of 5 nodes with a k-safety setting of 1. Vertica creates k copies of each projection, called a buddy projection. Because the k-safety setting for this cluster is 1, only 1 copy will be made. Each of these buddies is stored on the neighboring node in the cluster. This arrangement allows for node failure. If one of the nodes temporarily goes down, your database will still remain functional until it is brought back up, because the data in each segment is still available from another node. Vertica runs on industry-standard computers and storage devices under the Linux operating system. It does not require a special build-out of the servers and uses standard ANSI SQL syntax for queries. All nodes in a Vertica cluster are peers. We recommend that all nodes in a cluster be homogeneous or have the same configuration. Because Vertica has been proven to scale efficiently and effectively, this will allow nodes to be added or removed as needed. Massively parallel processing allows all nodes to participate equally in database processing. Queries will have access to resources across all the nodes in the cluster. Along with the buddy projections, this prevents having a single point of failure if nodes become unavailable. Vertica helps you derive more value from your enterprise data warehouse and data lakes. You will be able to get to market faster with your analytics initiatives. This is done through support for all leading BI, ETL, and visualization tools, open source technologies like Hadoop and R, and built-in analytical functions. If you already have a preferred tool, you can use them. Vertica does not force you to work with specific applications. Vertica is the ideal database for large-scale performant analytic queries over vast amounts of data. The database is ANSI SQL compliant, so you don't have to learn a whole new language to work with it. In addition to standard SQL functions, Vertica has extended the SQL analytic function set to make it easy to perform advanced analytic processing on your data. You can fill in the gaps in time series data, process time-based joins between disjointed data sets, automatically determine if your data matches stated conditions, and look for recurring patterns in your data. Vertica includes libraries that allow you to analyze geospatial data using standard SQL commands. It is also built to handle both structured and semi-structured data, using native flex tables or through accessing a Hadoop data lake. And finally, Vertica can perform predictive analytic functions natively and in database, using either the R statistical package or inbuilt machine learning algorithms. You have many options for how you can deploy your Vertica environment. The Enterprise license allows you to build your clusters on your own hardware in your own environment. This option gives you the most control over your deployment at the cost of having to maintain that environment. Vertica is also deployable in the cloud. We have deployment images designed for Amazon, Azure, HPE Helion, and others. And finally, we can interact directly with data lakes in Hadoop with the SQL on Hadoop license. You have the choice of importing Hadoop data into Vertica or accessing the Hadoop data without moving it. Thanks for watching. You now have a high-level overview of the value proposition provided by Vertica. In the Vertica Essentials instructor-led course, you'll learn more about each of the topics raised in this video. The Vertica Descriptive Analytics course introduces you to the SQL standard analytic functions, as well as shows you how to use Vertica's analytics SQL extensions to better analyze your data. The Predictive Analytics course introduces you to concepts involved with machine learning algorithms and how those algorithms are implemented. Look in the notes below for a link to the course registration system. And finally, you can access the full Vertica documentation set from the My Vertica portal. A direct link to the section on Vertica concepts is also in the notes below.